In this video, we'll be talking about changing fractions to decimals. So first thing we have to do is we need to think about what that fraction bar means. So for example, let's say I have the fraction 1/2. Now most of us should know right off the bat what the decimal form of this is, so it makes it easier for us to use this as kind of a check. Okay? So the fraction bar is also representative of a division symbol. Another way to write this would be 1 divided by 2. This is a completely valid way to write fractions and decimals, or sorry, fractions and division. So what I'm going to do to change a fraction into a decimal is I am simply going to divide. Now, when I'm dividing, I'm always going to put the numerator inside and the denominator outside. A little tip we can use to remember this is T-bow. Top in, bottom out. Okay? T-bow. So I am going to look at the inside and I'm going to think, how many times does 2 go into 1? Well, it doesn't go into 1 anytime, so I'm going to put a 0 there as a placeholder. Now I'm out of numbers inside, so what I'm going to do is I'm going to put a decimal, but if I place a decimal inside, I'm going to place a decimal on the top as well. Okay? So I have 1, and then I'm going to place another 0, because after a decimal place, I can write as many zeros as I want, and that's not going to change the value of a number. Okay, so I'm going to look here and I see how many times does 2 go into 10. Well, this time 2 does go into that number 5 times. And I'm going to say 2 times 5, right? 2 times 5 equals 10. Now I'm going to subtract this to see what I'm working with and what I have left. In this case, that cancels it out and I have nothing left. So the decimal form, as I'm sure you were aware, of 1/2 is 5/10 or 0.5. Another example we can look at is 5/6. So let's say I have 5/6. Now, when I am dealing with 5/6, I am going to again use that little T-bow trick, top in, bottom out, or numerator in, denominator out. But T-bow's a little more memorable than N-I-D-O, I guess. Whatever works for you. So I'm going to put 5 inside, 6 outside. Again, 6 does not go into 5 any times. I'm going to put that 0 up top, and I'm going to start placing my decimal and some zeros inside that aren't going to change the quantity of that inside value, okay? So how many times does 6 go into 50 now? Well, that number's a little bit higher. We have 6 times 9 is 54, so I'm going to jump down to 6 times 8. 6 times 8 equals 48. And then when I subtract 50 minus 48, I end up with 2. So I'm going to bring that 0 down from that I put in earlier to keep this going and see what's happening here. Okay? Now, 6 into 20. How many times can I put 6 into 20? Well, that would be 3, because do a different color here so it's a little more obvious. 6 times 3 gives me 18, and I end up with a 2 again. Okay? Now, if I drop another 0 down, you notice I have a 20 here and a 20 here? Well, that's going to keep happening. I'm going to keep ending up with that same number because 6 times 3, which is what I plug into there, is going to keep equaling 18 no matter how many times I change it. So I'm going to keep ending up with 2 and bringing down another 0. We call this a repeating decimal because that 3 is going to repeat forever and ever and ever and ever and ever. No matter how many times I subtract 18, I'm still going to end up with that remainder of 2 to carry on. So 5/6 is equal to 0.8. And I'm just repeating the 3, so I'm going to use that repeating bar, that line that goes above a decimal, to show that it repeats. I'm just going to put that above the 3's because only the 3 is repeating. Another example we have is going to be 10/9. Okay? Now in this case we have an improper fraction, so I'm going to have this come out a little bit differently than what I have, but it's still going to be a similar process. So again, numerator's going inside, 10. Denominator is going outside, 9 T-bow, top in, bottom out. And I am going to look and see how many times does 9 go into 10. Well, in this case, 9 does go into 10, one time. And I subtract that 9, and I end up with 1 remaining. Since I have a remainder, I'm going to keep this decimal going by placing the placeholder 0 and my decimal place. And I'm going to bring that 0 down. Now, again, how many times does 9 go into 10? You notice that we're ending up with that pattern like we did last time, right? So I'm going to put 9 goes into 10 one time. And I'm going to subtract 9 times 1, which is 9. And I get 1 again. Placeholder 0, bring it on down. And it goes in one time. Everyone's seeing the pattern here. So I end up with this pattern of just the 1 being left every time. So again, we have a repeating decimal, but this time, because it's greater than our denominator, our numerator is greater than our denominator, we end up with a mixed number essentially. So 10/9 is equal to 1 and 1 repeating. Okay? When we're repeating a decimal, we do tend to just put the repeating bar above anything after the decimal point. Even though the same number is in the front of the decimal point, we're still going to keep it after the decimal to show that part is repeating. Last example, 17/20. Not repeating this time, but I wanted to show you a slightly bigger set of numbers here. So we have 17 inside, 20 on the outside. 20 does not go into 17, goes into it 0 times. So I am going to place my decimal. As soon as I place it on the inside, I place it outside and just set myself up good to go. So 20 does not go into 17, but it does go into 170. It goes in up to 160, which would be 8 times. So 20 times 8 would give me 160. 17 minus 16, 0 minus 0, and 17 minus 16 is going to give us 10, which is not quite done yet, but I'm going to place another 0. And always check out at least a couple of decimals afterwards. 100. 20 does go into 100 evenly, so this is a terminating decimal this time instead of repeating. 5 times 20 gives me 100 also, and we are done, and our decimal is for 17/20 would be 85 hundredths. Happy practicing!